Hello and welcome to this month's SNOMED CT research webinar. I'm Susie Roy, the Customer Relations Manager for the Americas and the Research Engagement Lead at SNOMED International and the host of the SNOMED CT research webinars. As always, I have just a couple of housekeeping items before we begin. You'll notice that as you enter the Zoom webinar, you are muted. If you have any questions as we go along, please enter your questions into the Q&A box. It sounds like Michael and Jacee will be also monitoring the Q&A box, and we'll do a thing where we'll have some discussion as they go along. So please feel free to either raise your hand or place your questions in the Q&A box. This webinar is being recorded and both the video and the slides will be made available later this week. Our SNOMED CT web series have actually become immensely popular monthly events. Of course, I like to say that you, our research community, has made our research web series the main event, and that's really what kicked off the success. But of course, I know that it's our total SNOMED CT community that has really enjoyed the web series. So in addition to the research web series, we also have a clinical and implementation tracks where these are really focused on clinical implementations of SNOMED CT. These are always free of charge, so all you need to do is register because we use the Zoom webinar platform. So you can register at snomed.org/webseries for any of the upcoming presentations and also to see what's coming up next. And of course, to give you a little bit of heads up, our November research webinar will feature Dr. Meicheng Gong of China. He will be presenting SNOMED CT, bridging the RWD databases across the countries to empower studies on COVID-19. Right now, Dr. Gong and I are working out the details of the timing, a little bit of a time difference. So that information will be announced soon, so please stay tuned. And if you'd like to be informed of our upcoming research webinars, you can register for our research reference group. This is really where I can do a push notification to let you know of any upcoming research-related news. In order to join, you just need to email me, sro@snomed.org, and I will get you on that list. And one last little bit of information before I hand this over to our presenters. Looking at the attendee list today, I know a number of you were able to register for the SNOMED CT Expo that was held the previous week, but I just wanted to remind you and also those who were not able to attend that while it was really, couldn't see our SNOMED CT community in person, but having this virtual event was absolutely awesome. It was our largest crowd ever with over 60 nations represented. So I just really wanted to remind you that you're still able to access any of those presentations, tutorials, and the e-posters over the next 3 months free of charge. You can go to snomedexpo.org to view any of that content. And if you have any questions, feel free to email me and I can help you out. All right, so I'm immensely pleased to introduce our two presenters. Both Michael Denton and Jacee Robison have come to us from 3M and are from the Healthcare Data Dictionary, HDD team. Michael is a healthcare professional with experience as a nurse in the ER, OR, and medical surgical units, just to name a few. He has a Master's of Science in Nursing Informatics from the University of Utah, and currently is leading projects including terminology mapping and concept development using SNOMED CT, BOINC, ICD-10-CM, ICD-10-PCS, ARCS-NORM, and other terminology standards. Jacee is also one of those incredible healthcare professionals, also with nursing experience in the ER, ICU, and multiple surgical units. Jacee has a Master's of Science in Nursing Informatics from the University of Utah, and she is currently involved in terminology mapping and design development for multiple projects to improve interoperability in EHRs and the implementation of meaningful use value sets. Today, Michael and Jacee will be presenting transitioning from text-based to code-based NLP rules using SNOMED CT for data normalization and standardization. And with that, I will hand the screen over to you.
All right, thank you, Susie. Okay, Susie, can you see my screen just to confirm?
Yes, perfect.
All right, well, we'll get started then. Okay, so today we'll be discussing a pilot project that involved evaluating the feasibility of using SNOMED CT concepts to discover clinically relevant information from free text narratives through an existing natural language processing application using hard-coded text strings. So first, looking at image 1 on the top right-hand side of the slide, we've displayed some examples of the hard-coded text strings being used by the NLP application to suggest medical diagnoses, diagnostic tests, and supporting clinical information to end users from clinical narratives. Beneath image 1, we've shown an example of the hard-coded text strings as recorded by end users for capturing each unique variation of clinically relevant information. In these examples, you'll notice multiple levels of granularity in the amount of information recorded, perpetuating redundancies and inconsistencies in the amount of information required to comprehensively capture clinical information. So, what was this project trying to accomplish? Well, the legacy NLP application required users to manually add hard-coded text strings to ensure that every variation of a clinical concept would be found in free text narratives. By requiring users to manually add hard-coded text strings with no standard or structure to follow, and for every variation of a clinical concept, the process quickly became inefficient and resource-intensive for users. After identifying these issues with the legacy NLP application, we set a goal to improve the accuracy and amount of clinical information discovered by implementing a terminology model to normalize and standardize hard-coded text strings. We believe that by implementing a terminology model and utilizing SNOMED CT as our structured terminology, we can improve the scaling and maintenance of the NLP application through a normalized and standardized code-based approach. So we began the project by transitioning from text-based to code-based NLP rules through mapping. Each legacy hard-coded text string would be evaluated by subject matter experts, and the clinically relevant information within each text string would be mapped to equivalent pre- and/or post-coordinated SNOMED CT concepts. When equivalent pre-coordinated concepts were not found, subject matter experts would apply mapping heuristics to determine a set of post-coordinated terms that, when combined through a terminology model, would suggest semantically equivalent clinical concepts as identified in the hard-coded text strings. In addition to mapping hard-coded text strings to codable concepts, we utilize the terminology model to create groupings of like terms, capturing lexical variations of a concept. Take, for example, the hard-coded text string diabetes mellitus type 1. Diabetes mellitus type 1 can be represented in multiple formats, such as DM1, type 1 diabetes mellitus, or type 1 diabetes. The terminology model allowed us to add synonyms to terms used by a concept and can be reused across other concepts that use the same semantically equivalent terms. This included abbreviations and contextual variations, such as pre or post tenses, or differences between using a term as a verb or a noun. So I'll now hand over the lecture over to Jacee Robison, who will be discussing our methodology and the approach to mapping hard-coded text strings to codable concepts.
Thanks, Michael. As Michael mentioned, I'll be going over the methodology that we used in our project. Our methodology consisted of 3 phases: evaluation, mapping, and modeling. The evaluation phase included analyzing the 11,106 hard-coded text strings. In our evaluation, we completed a high-level assessment of the text strings, and subject matter experts identified patterns and developed mapping heuristics. These heuristics were used when interpreting and mapping the clinically relevant information contained in the hard-coded text strings to equivalent pre- and/or post-coordinated SNOMED CT concepts. The mapping phase involved creating a map set between the legacy hard-coded text strings and SNOMED CT concepts. We utilized an approach of mapping one-to-one, and in the instance a one-to-one mapping wasn't available, we mapped one-to-many. Also, subject matter experts mapped to equivalent pre-coordinated concepts. When a pre-coordinated concept did not exist, post-coordinated concepts were mapped. Now, I'd like to walk through the phases we've covered so far by showing you a small set of the hard-coded text strings we received and reviewed. You'll notice the multiple strings are expressing the same thing, but are represented using different language. Chest x-ray is performed, chest x-rays were performed, chest x-ray was performed, and chest x-ray was obtained. The hard-coded text strings in this example are all denoting that a chest x-ray procedure was done. So putting into action our mapping heuristics, we would map all these hard-coded text strings to the same SNOMED CT concept, chest x-ray. In the modeling phase, we created pre-coordinated concepts by combining post-coordinated terms to cover clinically equivalent concepts identified in the text strings. Looking at image 2, this shows an example of a one-to-many mapping and the mapping to post-coordinated concepts in order to combine into pre-coordinated concepts. The hard-coded text string has chest pain with acute dyspnea, does not have a pre-coordinated SNOMED CT concept that is representative of both clinical concepts, chest pain with acute dyspnea, that we could map one-to-one. So instead, we mapped the two clinical concepts within this hard-coded text string, which are chest pain and acute dyspnea. SNOMED has a code for chest pain, so we were able to map the chest pain portion to the SNOMED CT concept chest pain. However, there isn't a pre-coordinated code for the term acute dyspnea, so we map to the post-coordinated concepts of acuteness and dyspnea. By using a terminology model, we were able to combine post-coordinated terms into a pre-coordinated concept and then also add clinically equivalent synonyms. As Michael mentioned previously, we were able to add synonyms and abbreviations in the NLP application. In this case, we added synonyms such as chest pains and the abbreviation CP for chest pain, acutely and acute for acuteness, and the abbreviation SOB and shortness of breath for dyspnea. These synonyms are also able to be reused across other concepts that use the same semantically equivalent terms. For example, if we had another concept that was chronic dyspnea, we could reuse the synonyms we created for dyspnea, the abbreviation SOB, and shortness of breath. In our review, we also encountered hard-coded text strings that had contextual information included. Our NLP application was able to handle contextual language and information, such as temporality, which includes recent, historical, and hypothetical, experiencer, which includes patient and other, and polarity, which includes negation and assertion. Because the NLP application was able to capture this type of information, we did not have to map to SNOMED CT concepts that included contextual meaning. For example, if we encountered the text string, patient denies chest pain, the NLP application would recognize that the language denies denotes that the patient is not having chest pain and would mark the context for that phrase as negated. Because of this, we mapped the SNOMED CT concept chest pain. Another example is if the text string was patient has a history of heart failure. The NLP application would identify that history of is historical information, so we mapped the SNOMED CT concept heart failure. This functionality in the NLP limited instances of excessive pre-coordination. Also, our NLP application was able to pair relevant terms together if found in a discontiguous format or in a contiguous format. We were able to constrain the NLP to find and link terms found discontiguously and contiguously to a sentence-level scope. There are other constraints in the NLP to find and link terms found in the same region or same document. However, they were not used in this project. Here's an example of pairing relevant terms together when they are documented in a narrative discontiguously. The patient taken by rad tech for an x-ray of his left ankle. The term x-ray and left ankle are separated by the words of his. Using our NLP application, we were able to create a rule that specified if the terms X-ray and left ankle were found in the same sentence, produce the SNOMED CT concept X-ray of left ankle. Similarly, here's an example of pairing relevant terms together when they are documented in a narrative contiguously. The patient taken by RadTech for a left ankle X-ray. The term left ankle X-ray is not separated by any other words. Using our NLP application, we were able to create a rule that specified if the term left ankle X-ray was found in the same sentence, produce the SNOMED CT concept X-ray of left ankle. And Michael will now go over our results. So Michael, back to you.
Actually, right before you guys get into the results, if you don't mind, it looks like there was a question for you, Jacee, from Rita Pyle. How would you know acuteness qualifies dyspnea and not chest pain, i.e. acute chest pain versus acute dyspnea?
Oh, Jacee, I don't know if you're still muted or not.
Yep, I was, sorry. Let's see. Okay, so that's the second one. That's a good question. Let's see. Where is that? Michael, can you go back to the method? Sorry, I can't find
Sure.
I'm having trouble looking at the example.
Not a problem.
Okay, so it's that image 2, has chest pain with acute dyspnea. In this example, so this would be part of our evaluation, and so subject matter experts would have determined that the acute dyspnea is referring to, that the acute part is referring to the dyspnea and not the chest pain, just how it's ordered. Michael, do you have any other comments?
So this was a particularly difficult challenge with a couple of specific examples. So the example we included here has chest pain with acute dyspnea. What you're seeing here is an exact representation of the hard-coded text strings that we had received, with no other contextual background or knowledge of how these disorders or findings were paired together. So we really were just assessing them at face value like you are here today. So when we started looking at these, in this instance, we can generally assume that obviously acute is referring to dyspnea in this scenario just because of the word pairing. Now, however, I'm sure we've all seen multiple examples of going through problem lists or patient narratives where an annotator will write something such as patient has acute symptoms of, and then a certain set of disorders and findings, and trying to determine if acute applies to all of those disorders and findings or just an individual set of them is one of the complexities we had to look at. So we did evaluate at the level of what we considered the most specificity for a concept, or the most granularity. We really tried to look at if we could identify a clinically relevant concept, and this is one thing that's not clearly shown in this image, but we wanted to look at all specific representations of a concept that we could add. So if we saw acute dyspnea or dyspnea, we'd also want to evaluate of all the different types or specific instances that dyspnea could be represented in. The same thing would apply for chest pain as well, is if we identified a clinical concept of chest pain, we'd also want to note all the potential other variations of chest pain. And if acute chest pain was one of those, then we would look to include it within our map set. Okay, and it looks like we have.
Looks like we got one more question, if you don't mind, from John Schneider from the National Library of Medicine. What was the purpose of extracting X-ray information using NLP when there should have been an ordered procedure and interpretation that are associated with a LOINC code?
This is a really great question, and it was one of our frustrations initially going into this project is we actually did not have access to any of the structured information being used behind these patient narratives from the EHR applications. So for the purpose of this pilot project, we were sticking to just unstructured clinical narratives, and that was the entirety of the documentation we had exposure to. Now, what you don't see is future efforts. We have looked at incorporating types of structured information, such as you've indicated, using LOINC codes that would be structured with that procedural order and or the result and interpretation. And the same thing applies in other areas, such as using the MAR for medications and things like that. So just for the purpose of this project, this was strictly looking at how much information that was clinically relevant that we could extrapolate from clinical narratives. So we didn't necessarily take a focus as to one type of concept type or another. We really just looked at including as much comprehensively clinically relevant information that we could capture. Okay, and it looks like we have one more question. I think we can go ahead and ask that and then.
Results. Yep.
Sure. Okay, it says, how did you select the text strings that should be mapped? Was it manual work by the subject matter experts, or did you use the NLP pipeline to separate the text into chunks? There's a part of this we'll talk towards the end of our slides, specifically into the NLP dividing things into chunks. But really what this was is actually was a manually intensive effort. And when we say legacy and NLP application, it was a not a very robust clinical application that coding analysts were actually using. And they had to annotate every variation. So the text strings that you were seeing and we were trying to determine from a map set was really just a list of evidence that people had captured, de-identified patient information that we were just set to evaluate and find clinical relevance. Now, from the legacy NLP application standpoint, they really were using each one of those variations to capture what they thought to be clinically relevant. So when Jacee showed the different examples, and here I can bring them up again, for X-ray, is we had the previous coding analysts were having to look at every clinical variation, and if each clinical variation wasn't captured, it had to be accommodated for. And the level of specificity that they were capturing this information at was inconsistent. They didn't know how much or how little they would need to capture to get the correct content suggested to them that they wanted. So from our perspective, we really took it as an approach of, if we can find a structured concept to map these text strings to, so even if we had to use the language such as performed or obtained to further specify what is happening with the chest X-ray procedure, that was definitely a level of specificity we looked at, but was not necessarily a requirement. So the best way I can explain this is looking at these 4 chest X-ray examples. We saw these just as such, and we tried to identify what are the key focuses of these text strings based off of our subject matter expertise, who were built off of backgrounds in nursing and pharmacy and laboratory domains. So it's really just clinical expertise in trying to recognize from a patient narrative, what might they be trying to capture based on this text string. Okay, I think we'll go back on to the results slide. Okay. All right. Okay, so in total, the project resulted in 11,106 text strings being mapped to 6,657 unique codable concepts. And by normalizing text strings to SNOMED CT concepts, we were able to create a standardized approach for scaling and maintaining the terminology used by the NLP application. The resulting number of concepts was almost half of the original number of hard-coded text strings being used to suggest medical diagnoses, diagnostic tests, and supporting clinical information. However, just like my colleague Jacee Robison demonstrated in the previous slide, we were able to limit redundancies by mapping clinically relevant information found in the legacy text strings to the most specific atomic concept. Then, by using a terminology model, users were able to structure our atomic concept with additional semantically equivalent synonyms for terms used to define the concept in multiple lexical variations, eliminating the need to record every clinical variation of a concept, including instances where terms used to define a concept were the same, but structured in varying word orders. For example, let's look at image 3 on the right-hand side of the slide. The image displays the original clinical narrative from our first slide, demonstrating the hard-coded text strings being captured by the NLP application and suggested to end users. You'll notice that in each example, the clinical information being suggested by the NLP application contains noise or otherwise irrelevant information. In the first suggested text string, we note that the patient underwent a procedure to incise and drain an appendiceal abscess by transabdominal approach. Once evaluated by our subject matter experts, we determined the relevant clinical information necessary to map the text strings to an atomic SNOMED CT concept was incision and drainage of abscess of appendix procedure, noted in Table 2. Once mapped to a SNOMED CT concept, we use a terminology model to refine the terms and structure required for the NLP application to suggest a codable concept. So now highlighted in green, you can see the terms incision, drainage, and appendiceal abscess suggested by the NLP application. All highlighted terms and their associated colors correlate with a codable concept found in Table 2 on the left-hand side of the slide. By using a terminology model, we were able to take pre-coordinated concepts or a combination of post-coordinated concepts and determine the key terms necessary to suggest a clinically relevant codable concept. This allowed us to use multiple terms for each contiguous or discontiguous variation of a code display. So in our example procedure, incision and drainage of abscess of appendix, we're able to add the terms of incise, incised, incising, and incisions to the term incision as synonyms. By using a terminology model and mapping clinically relevant content to an atomic concept, we were able to create a normalized and standardized dictionary capable of comprehensively capturing multiple formats and lexical variations of the concept. This process also enabled us to suggest content with different levels of granularity, capturing additional information that indicates the context or intention of a concept. And this includes information specifying temporality, including whether information is historical, current, or hypothetical, the experiencer, and whether the narrative is capturing content in relation to a patient or family member, and assertion and negation, whether the narrative is suggesting whether something did or did not happen. Okay, Jacee, I'll let you take the lead now.
Thanks, Michael. Now that you've heard some specifics about this project, let's go back and review the purpose of this project. The legacy NLP application required use of hard-coded text strings to capture every clinical variation and variations of contextual information. This was the only way to ensure that every variation of a clinical concept was found in free text narratives. This process was inefficient and resource-intensive for users because it required manually adding all the text strings. Setting out to improve upon this previous process, we implemented a terminology model to normalize and standardize the hard-coded text strings. We utilized SNOMED CT as our structured terminology so we could improve scalability and maintenance of the NLP application through a normalized and standardized code-based approach. This conversion wasn't without challenges. However, developing mapping heuristics facilitated in capturing multiple levels of concepts and utilizing pre- and post-coordination allowed for the important clinical concepts to be mapped from the hard-coded text strings. Keeping in mind that our NLP application could account for contextual considerations such as temporality, whether the narrative signifies if the clinical content was recent, historical, or hypothetical, experiencer, whether the information pertained to the patient or someone else, and polarity, whether the narrative indicated clinical information did or did not happen. The NLP application allowed for capturing clinical information that was documented discontiguously and contiguously, thereby further improving upon the previous process. In addition, being able to add synonyms to clinical concepts helped in capturing abbreviations, pluralizations, and different tenses of the concepts. This project has become much more efficient and generalizable process and has significantly improved upon concept scaling and maintenance. And Michael will talk about our lessons learned and kind of our future directions. Back to you, Michael.
Awesome. Thanks, Jacee. Okay. So one of the lessons learned while working on this project was the immense complexity and variation in unstructured clinical documentation. So this presented a challenge to our team as we worked to create a process to comprehensively capture clinical information for what felt like a constantly moving target. However, by using a structured terminology such as SNOMED CT and a terminology model to accommodate lexical variations, we are able to normalize our legacy text strings to a standardized terminology, creating a comprehensive dictionary of clinical content that can be discovered and suggested by the NLP application. So in addition, one of the lessons learned from this project was the need for a flexible terminology structure to accommodate the clinical variations we encountered. Overall, we were able to map the legacy text strings to SNOMED CT codable concepts. However, there were multiple instances where the structure of SNOMED CT did not meet the requirements for our NLP application in order to accommodate all unstructured variations of a clinical concept. So moving forward, we recommend using a SNOMED CT extension. By using a SNOMED CT extension, users can create concepts that are customized to address terminology needs not met by the International Edition. Specifically, creating additional pre-coordinated combinations, post-coordinated terms, and clinician-friendly synonyms. And by utilizing SNOMED CT, understanding the structure and foundation of the SNOMED CT terminology model has enabled us to evaluate the use of bulk content creation. The SNOMED CT expression constraint language, or ECL, helps users of SNOMED CT content to identify groups of like content with the same definitional relationships, enabling us to build and capture multiple levels of granularity for a given concept type, such as concepts using the same body structures, associated morphologies, or procedure methods. Additionally, one of the considerations we recognized was the need for cross-terminology mapping. SNOMED CT is a robust clinical terminology, but gaps do still exist in specific content domains such as pharmacy, laboratory, and imaging. Evaluation for the use of RxNorm for generic versus brand name medications and LOINC for laboratory testing and imaging procedures will potentially add additional layers of complex terminology coverage. Lastly, we recognize that moving forward, we'll need to perform data-driven testing to validate the increased discovery and suggestion of clinically relevant content for our end users. Data-driven testing would help us by evaluating gaps in coverage or differences between legacy text strings and codable concepts. By creating a foundation for the NLP application by using a structured terminology, we'd like to tackle maintenance and scaling through a programmatic approach that analyzes patterns and phrase usage of mapped concepts. Later steps would include evaluation of predictive models for identifying groups of content requiring further normalization and determining the weight and relevance of currently suggested content. Okay, well, that concludes our presentation on transitioning from text-based to code-based NLP rules using SNOMED CT for data normalization and standardization. We'd just like to say thank you to Susie and the SNOMED Research Web Series group for allowing us to participate in today's webinar. We hope that you learned something useful in today's session, and we'd like to let you know that if you have any questions, which I know I've been seeing a bunch come through, we'll be happy to answer them to the best of our ability and stay on as long as you are here. All right, thank you, Susie.
That was excellent. As soon as I saw your abstract come in for the expo, I knew we had to present this. So thank you both for agreeing to do this presentation. A quick turnaround right after the expo, so thank you. So yeah, people are very, very interested. We have a number of questions. So I will go through. We have a couple in the chat that I'll get through because I think that those are quick. Then we have a couple in the Q&A box, and then I have one or two hands raised. So just going through these now. From Vassos, if the physician has written that not taken for left hand x-ray, even though it was very painful, but for right hip, because you could see the bone due to skin rupture, how do you proceed with this? That one's in the chat box.
Okay, I'm looking at it right.
Directed just to the panelists. So.
Okay, so it's saying like that an x-ray of he was taken for an x-ray of the right hip is what you're kind of infer from that is what? I'm guessing. Okay.
And left
Yeah,
hand.
that type of stuff we're still kind of working through. It's very, like, as he's pointed out, it's very difficult to capture things like that where they say not taken for, left hand x-ray, but as a person like me reading it, I can assume and like infer that he was taken for an x-ray of his right hip. But for a computer to figure that out, it's definitely it's a much more difficult. So we're still kind of working through that. Yeah, hopefully that answers the question. I don't know if you have anything to add, Michael.
No, I'd agree. I think that's just an ongoing. It's one of those constantly moving targets where we're still trying to figure out the best way to capture that information.
Staying in our little chat box here, Peter asked, are there projects to offer this for other languages?
That's a great question. So one of the things we have looked at, and I'll answer this quickly because it goes a little bit beyond the scope of what this project is specifically for. But by tying these clinical variations and lexical variations to a single codable concept, specifically an atomic concept, our goal would be to potentially look at incorporating other languages with the same semantic equivalence to those root atomic concepts. So we have evaluated looking at that and making that potentially a future project that we work on in addition to what we're currently doing, but has not been done so at this time.
And Lee Trezzi has a question that I was also wondering. The examples given are all quite well written in plain and correct English. How has this fared against real world examples like shorthand and typos and things like that?
Yeah, this is a good question. Like Lee's saying, we wish that all the narratives could be that plain and simple, right? That everything would be documented correctly. But we do have a process where users that are evaluating what the engine has found, and if they do come across like shorthand and things like abbreviations, things like that, they can report that, and we can decide if we want to add those. There's a few problems with some of the abbreviations, like PE. It can mean different things, right? So yeah, that's a good question, but we do have a process to report those. So we just have to kind of evaluate those and see if they're appropriate to add.
Mm-hmm.
Yeah, I think that's such a good point. I mean, abbreviations are probably the simplest way to look at those types of clinical variations that are really challenging. The example Jacee said, PE, is it pulmonary embolism? Is it pleural effusion? Is it physical examination? What is the context of how it's being utilized? Jacee talked about this a little bit in the methodology. And again, I won't go too far into depth with it, but we did have to look at the NLP application's ability to evaluate the section or the header that a content's being suggested under, to recognize potentially the unit or the hospital or the facility that may be specifically using that information. And maybe that also helps dictate at the provider level. Is a provider part of a certain department that is always doing physical examinations versus a pulmonologist who is always identifying pleural effusions and pulmonary embolisms? So trying to capture that has been very, very difficult for us. We have limited the amount of abbreviations we try to suggest from because of that, and we realize that more times than not, contextually, they're misrepresented. However, there are also a lot of other clinical variations, probably the most common being misspelling. And that's been something that's been very difficult in trying to decide if we include iterations of misspelled words, even if they're common misspelled words. So these are some things we've looked at and we talked a little bit about towards the end using data-driven testing. Is we would like to reflect on some of the mappings and the synonyms we're currently utilizing and look at what type of real real world phrases, such as those misspellings and abbreviations, and see if we can identify trends in the commonality, the usage, and actually define the contextual meaning of those to make sure that we're adding them appropriately to suggest in any instance. And I think that's the hard thing, is right now we're just looking at it from a comprehensive standpoint and trying to suggest all content, all clinically relevant content that we can find. But obviously, as we get more specific and we start to understand the terminology better and how it's suggesting content, we'd obviously like to make sure that we can identify those specific examples in their correct contextual intention.
Great, thank you. So we have a number of questions coming in through the Q&A box, and let me do a quick little time check. Okay, so I think we're good right now. So I'll go through some of these questions. I'll read them out loud to you. So I'm in the Q&A box now. John Schneider asked, what percentage of clinical content found in the text strings was not found in SNOMED CT, i.e. 1 to none mapping?
That's a great question. So the simple answer is we don't have a number to give you on that. And I think part of that was the way we utilized SNOMED, in that we were not confined to only using pre-coordinated or post-coordinated terms, and that our terminology model allowed us to have a flexible structure that, so long as we had the terms necessary, we could build that single atomic codable concept to utilize using the SNOMED either post-coordinated terms or a single codable concept. So beyond that, at a high level, I can say I don't think there were many instances where we were not able to find some equivalent concept or term to use, or it was at least few and far in between. But we do plan to do a second iteration of this project based on our current development, and it will touch more along those lines of one to none mapping, one to one, one to many, and where some of those more specific gaps exist. I don't know, Jacee, if you have anything else you'd like to add to that.
Yeah, I was just going to say, we're still kind of in process with this project. So I think, after we get around to finalizing it, it would be good to, get a percentage get a number for this. So.
Next question comes from my colleague Yang Gao from SNOMED International. Why the concept 667390002 abdominal approach, which is a qualifier value, which has a synonym of transabdominal approach, was not highlighted in map? We would assume that synonyms and terminology have been utilized for mapping.
Yeah, no, this is a great question. And this was a challenge for our subject matter experts. So one of the things we look to do, and we talked about this a little bit, is trying to capture and suggest this content at multiple levels of granularity. So I agree that from just looking at the instance that we displayed, we did not obviously include the abdominal approach, which would obviously help suggest the more specific procedure that addresses the approach method of how they got there. Now, in that instance, we did not display that, but if the code was available, kind of like I talked about at the beginning, and trying to capture those multiple levels of granularity, if that was something we were looking at for an incision and drainage of abscess, and we found that term as an appropriate one to add, it would be one of the multiple levels of granular concepts that we chose to map for this example. The other side of it too was, it is also looking at how our subject matter experts approach this, is they were trying to capture the most specific clinically relevant information possible, but also at the same time not create excessively pre or post coordinated concepts. And part of that was because we were really trying to understand what is the required necessary terms that a clinician would actually be interested in knowing. What do they need to know to have some information suggested to them? So at its root, and I could say this for that concept example in particular, is we only needed to have incision and drainage of appendiceal abscess, noting what was happening and the location that it was occurring at. Any other additional contextual information is helpful, and it adds more context to what is going on or how that procedure was done in that instance. But again, we're trying to take it at that root level. In that example, we didn't show that, but we could have that in our map set at just a different level of granularity.
Katrin Sherlink, I'm so sorry, attendees, if I butcher your names. How do you make a distinction between hierarchies throughout the mapping? For example, when speaking of a carcinoma, you can find an equivalent SNOMED CT term in the hierarchy of disorder and in the hierarchy of morphologic abnormality. But what concept you need depends on the context in these cases.
Jacee, do you want to take a stab at that one?
Yeah, I can. I mean, for most of the, like the disorders, we use the disorder hierarchy. Trying to think if we even used any morphologic abnormalities. Don't think we did.
Yeah, I think it was very limited instances that we did. We definitely tried to stay to the core hierarchies, being the clinical findings, which is your findings and disorders, the body structures and procedures and substances were the primary domains we looked at using. Now, however, we did look at, I think, a few instances of using the morphologic abnormalities if there was no other clinically identifiable concept using the same term. So again, we were not confined to necessarily the terminology model use for SNOMED and how they would use a morphologic abnormality in defining something that of how it's occurring or how a disorder is transpiring. But for us, like you indicated, if we recognized a SNOMED CT term that was a part of a differing hierarchy, being maybe just the morphologic abnormality, let's just say carcinoma, but we didn't have a note of a locality in relation to that, we could evaluate using that just for the purpose of suggestion and being able to show that we identified a carcinoma. But when possible, we look to always include that relational pairing. And that kind of goes to the different levels of like bulk content, like we talked about, is if we knew that we could identify a morphologic abnormality of carcinoma, and there was a set of concepts that identified the multiple locations that a carcinoma could be identified, then we tried to tackle it from that approach first and looking at having those more specific instances. And then in the instances where the body structure and carcinoma pairing was not able to be found, or it was still not suggesting the content that we would be expecting, then yes, we could go look to use a term that was maybe outside of our hierarchical preference.
Oh, you did have a hand raised. Someone was going to ask a verbal question. I think it was John Quayle was going to ask a question. John, I'm going to unmute you, and if you still have your question, you'll be allowed to talk, but if not, then I'll move on to the next question. So John Quayle, I have unmuted you if you wanted to ask your question. Or I guess I have permitted you allowed to speak, and you'll need to unmute yourself, sorry. If not, I'll move on to, we have a couple more questions in the Q&A box. Pim Volkert from Netherlands National Release Center asks, how much effort would it take to use NLP in another language, provided that SNOMED has been translated in that language?
Oh, that's a great question. Go ahead, Jacee.
Oh, I was just going to say, that's a good question. Yeah, I know that with translating, into different languages, you have to have certified translators when doing that type of stuff. I'm not sure how much effort that would take, but yeah, Michael, what were you going to say?
Well, yeah, so it really depends on how you look at using it. So I know from, yeah, like you said, JC, from SNOMED's perspective, I know you actually have to have a certified translator to be able to validate that the concepts have the same semantic meaning, and we haven't necessarily branched into that yet because the use case has not been presented to us. However, I think that emphasizes the need for having a terminology model to build upon, and is really the emphasis of the project and what we look to accomplish, of being able to take all of this information, and whether it's multilinguistic or whether it's just lexical variations between the same language, being able to tie that information to a root concept that you can say is semantically equivalent across multiple contextual variations or language barriers, I think is a key starting point. So there are instances where we could look to take equivalent concepts that are a part of a different SNOMED CT extension. I know we've previously evaluated to include the Spanish extension, or as well Germany's extension. So there are those options where we can look to take, again, that root concept and tie it to its semantically equivalent pairings across languages. But again, that just wasn't within the scope of our current project. So we'd have to evaluate that further.
Well, Pim is one of the leaders at the National Release Center in the Netherlands, and it is out of his shop where the Netherlands extension is created. So if it's something where you guys wanted to talk later offline with regards to a potential collaboration or furthering it, I will definitely connect you guys.
That would be fantastic. I mean, we'd love to see more opportunities of how to disseminate this information and really make it useful for other people in the industry who are really searching for all the potential clinical variability that is found in our documentation.
Awesome. Okay, and one more question that we'll wrap up with. John Schneider asked, as part of this project, was any evaluation made of the impact of the incorrect or incomplete modeling of SNOMED CT concepts made on NLP? Just as an example, laterality specific concept with a laterality agnostic body structure for finding site.
Yeah, JC, do you want to talk to this at all?
I'll let you talk about that one.
Okay. So the simple answer is yes, and I think this comes with being more familiar with SNOMED's terminology model as opposed to necessarily how we look at using it. And one of the things, and this actually relates back to a question that was talked about a little bit earlier, or asked a little bit earlier, about how users would look to map this information. You know, did we just look at all these narratives? How do they record all this information? And one of the things we looked at for scaling was, can we approach this if we identify a single idea? So I'll just say leg fracture, or let's just say fracture as a whole. And we know that comes across as an associated morphology. But we also know that in the finding and disorder hierarchy, that there are multiple disorders and findings that is the fracture of a certain locality, right? Being the individual bone structure that's broken, or as well just if they say arm or leg. So being familiar with the SNOMED terminology structure, we did look at, if we identified a single idea of a concept, so carcinoma, fracture, any of these potentially broad and encompassing disorders, we look to see, could we also, using ECL, look at other like concepts that maybe just use a different anatomical structure, but would still be clinically applicable and clinically relevant. Meaning that if our original legacy NLP text strings had only one instance of a fracture, we would look to try and incorporate all potential 100 or 200 variations of that fracture that SNOMED currently has, and as well, all the potential contextual and lexical variations of that. So being familiar with the SNOMED terminology structure has helped us with being able to capture what exists with laterality. Now, there were some instances where laterality, as we know, does not exist for all of them, and specifically, it could be And I think we've all experienced this in looking at SNOMED, where maybe they even have an existing bilateral concept, but the left and right side specific aren't developed. Or maybe they only have the non-lateralized form where no laterality is even specified. And from our perspective, we did try to take that with an approach of building based off of what SNOMED CT is able to offer us. But again, that goes back to using the terminology model and our familiarity with SNOMED CT and being able to identify if they don't have those current concepts available, but we can take post-coordinated terms that they do allow us to use, such as the qualifiers indicating laterality, in addition to a body structure and a morphology, and being able to create our root atomic concept. Our terminology and model allowed us to do that and create our own non-semantic identifier and create that lateralized form we might be looking for. Now, however, that's why we also are suggesting that there needs to be additional work in using the different SNOMED CT extensions, because I think this is a great opportunity that we can further build and add as a community to SNOMED CT, and trying to capture those gaps that do exist where we haven't come across the use case where we need those lateralities, and maybe we have, and just as clinicians and as informaticists, I think being able to give back to that only helps enable the community further. So that is something we're looking at moving forward. But again, everything comes back to the root of why we did this, and it's incorporating the terminology model and as well using the terminology structure that SNOMED gave us to be flexible when otherwise we didn't have a single codable concept we could go to.
All right, great. Thank you. Thank you so much, Michael and Jacee. Awesome presentation. That was absolutely exciting to see, SNOMED actually being used, and yeah, really looking forward to some of your future endeavors as well. And I know from our audience, it was exciting for them because we had a lot of questions. So my email is posted on here. So if there are any follow-up questions, anyone's feel free to email me back. Again, I'd like to thank you all for attending today, and thank you again to Michael and Jacee. And other than that, I will see you all next month. Thank you.
Thank you so much, Susie. Thank you, everybody.
Thank you. Yeah, thanks everyone. Thanks for the great questions.